everybody. Welcome to the show. My name is Professor Joseph Earl McPeek ESQ III, and tonight, I would like to talk about physics, light, cosmology, and some things that need to be talked about because the world is suffering from too many questions about physics, okay? And I know all the answers. I simply do. I mean, let me get some good music up in here. By the way, this is my music. And coming to you live from White Lake, Michigan, which is just outside Pontiac, which is just outside Detroit in Michigan. And let me tell you, I really think I know what's going on with physics and why it's so messed up. And it's not just to do with Einstein, it's to do with all of those guys. It has to do with light. Okay, my hair looks really stupid right now. What's going on? I'm sorry. God, I can't get it to flip the right. Joe? Yes, there you go, Joe. There you go. That's fine. All right. Now, you're not going to believe me when I tell you these answers. But let's just say I'm right, okay? And I think I am. That light don't move. Okay, it goes like this. 0.0.0. Okay? That's 1, 2, 3. That means 1 before the event, 2 the event, and 3 the aftermath. Okay? Light is 1. That's white. Gray is the lean, which is the slash, and matter is the 1, which is, 0/1. So it's a binary mechanic. Light interacts with matter. Okay? Now, there's 2 parts to light, and photinos play a role. Well, I call them photinos, but they're the neutrinos are part of the here I have to fix this. The neutrinos are part of it. So how am I going to explain this, guys? This ain't easy. We've been streaming 3 minutes and 44 seconds. Let's just start with always. Light don't move. It can't move because there needs to be something that doesn't move so matter does move, okay? So let's just say, get it out of your head, that light goes 665 point something million miles per hour because it doesn't. Okay, this is physics' fatal flaw in the beginning. When they tried to measure light, they didn't stop to ask themselves, well, why are we measuring light? Why are we trying to measure a limit? Right? So I got to thinking, yeah, why are they measuring a limit? And even if light did go that fast, which it don't, how in the heck could you ever catch up to it to measure it anyway? Okay, so here's physics' fatal flaw, and it's proved with 3 very easy scientific experiments, and we'll go over those in just a second. Okay, just a second. Um, okay, where was I? Okay, so light don't move, and that's the zero of the biomechanic. The slash one is the matter. Okay, the lean of the slash is the gray zone. The one is the black. Okay, that's number three. That's a Minkowski cube. You're now in 3D, and you now made a shadow. So all shadows have a story. That means it was real. Okay, if it has a shadow, it's real. It means it's lit Minkowski space. Okay, so I'm going to name the dimensions now. There's zero. That's light. That's the new constant. Zero equals C. Now, let me tell you before I explain. This is where Einstein went wrong. He was trying to measure a limit, which means he was sneaking up on the starting line instead of going towards a finish line. Which means he put a limit at the top. So at the top of the graph over here, at the top right of the graph, there's Einstein with his 665 million miles per hour. Now what's Joe going to do? He's going to take that speed limit, which is C, and he's going to pull it down over here, and he's going to put it right there. Right there, guys, that's zero. That is the new constant, which is zero, and that's for the new light speed. Okay, that's the new light speed, baby. Zero. I'm gonna explain more about that too. But so now the zero is over here at the right part of the graph, down in the right hand corner. That's where the zero should have been. That's where Einstein should have started. Now, we are in the middle. In fact, I have some diagrams, but we're not going to go through the diagrams right now. We'll go through all those diagrams later. But I've made all the diagrams explaining graphically and diagrammally what I'm talking about. Okay? Now I'm going to explain those dimensions. Zero is light. That's 0D. Okay? 1D is the lowest dominating denominator, and that's called the Planck floor. Okay? That's 1D. Now 2D is a latent field which computes in 2D, like a Commodore 64. Okay? So I did not know a Commodore 64 had all that graphics capability in there. But then it's 3D, which is a lit Minkowski cube. That means matter has interacted with light. Okay? Matter moves and light doesn't. Light is a lattice and matter moves through it. Light does not go 660 million miles per hour. You do. Matter does. Matter moves. Light can't. Okay, it's beautiful. By the way, light is beautiful. And you can never get behind a shadow. So there's an order in the life. There's an order. It's 1, 2, 3, ABC. There's an order. Light is first. Matter is second because it moves through the lattice. And and shadow is third. So light is white. Position 2 is gray. That's a gray scale of infinite gray shades. That's a compute zone. And then the shadow is always behind you. You can never get behind the shadow, okay? That's the order of the universe right there. A shadow is unused compute. After the light has interacted with the matter, there's a shadow. And you can see the shadow. See, there's shadows all over the place. That's proof of existence. Every shadow has a story. Remember that, guys. So we're going to go now. This has been an 11-minute physics masterclass on how light really works. And we have to explain much more than that. I see that now, and we will come back in just a minute and try to cover some of those subjects because it's hard to simplify it all, but we will try and do it. Okay, thank you for watching, folks. See you later.